Then next we continue the knapsack problem in pseudocode of the value of optimal solution among the all feasible subset of the first item is the maximum of these two values of Of course, if the item does not fit into the knapsack, the value of the optimal subset selected from the first item is the same as the value of an optimal subset selected by the first I minus 1 items. Those observations lead to following the recurrence f of I comma j equal to maximize f of I minus 1 comma j vi plus f of I minus 1 comma j minus wi into f of I minus 1 comma j. If j minus wi is greater than 0, then f of I minus 1 comma j, if I minus wi is less than 0. It is convenient to define the initial conditions as follows as the f of 0 comma j equal to 0 for j greater than 0 and f of I comma 0 equal to 0 for I less than or 0. Our goal is to find the f of n comma w, the maximal value of subset of n given item that fit into the knapsack of capacity w and an optimal subset itself for I comma j to compute the maximize the entry in previous row and the same column and the sum of vi and entry in the previous rows and wi columns to the left. The table can be filled the entire row by an entire either row by row or column by column. For the algorithm of the knapsack problem, dynamic programming in knapsack problem, in the weight of 1 comma n and v of 1 to n and w, the variable of v of 0 to n and 0 to w and p of 1 to n and 1 to w int for j equal to 0 to w do, then v of 0 comma j equal to 0 for I colon equal to 0 to n2, v of I comma 0 colon equal to 0 for I colon equal to 1 to n do, for j colon equal to 1 to w do. If w array of w of I less than or j and v of I plus v of I minus 1 comma j minus w of I greater than v of I minus 1 comma j, then v of I comma j equal to v of I plus v of I minus 1 comma j minus w of I into p of I comma j equal to j minus w of I, else v of I comma j equal to v of I minus 1 comma j into p of I minus I comma j equal to j, to return the v of n comma w and the optimal subset of the backtracking. Then next is in memory function. The memory function is the directed top-down approach to finding the solution to such as the recurrence lead to the algorithm that solve common subproblems more than once and hence is very inefficient. The bottom up fills a table with the solution to all smaller subproblems but each of them is solved only once and unsatisfying the aspects. This approach is the solution to some of the smaller subproblems are often not necessary for getting a solution to the problem. Since the drawback is the present to the top down approach, it is the natural to the combined strength of the top down and bottom up approach. The goal is to get the method that solve the only the sub problems that are uh, necessary and does not only once such the method exit. It is based on using the memory functions.